Can you share with us a little bit some of the technologies that you've assisted organisations with? What kind of sectors are taking advantage of the support that you guys offer at the moment?
So I mean, technology-wise, we've got a strong in-house knowledge and understanding of composites. It's obviously really growing manufacturing technology, really becoming much more mainstream with automotive, additive manufacturing techniques. So the 3D printing, but that is a fast-paced technology moving with some real opportunities to rethink how you design, rethink how you make. So that those are kind of probably two of the fastest growing areas that we see. But it comes down to things like inspection, looking at how we measure things, even looking at more traditional manufacturing technologies. We're here on the park next to the Advanced Manufacturing Research Centre, and they're in there optimising, subtractive technologies, milling, turning, and so you can find something that's been established and used for hundreds of years, and yet there is technologies being developed to halve the time to machine something and halve the cost. So there's really there's a whole host, almost in any area, materials, manufacturing, measurement, the design tools, they're all evolving so quickly, and keeping abreast of those is what gives us that advantage to give our clients the best solution possible. And then sector-wise, we still work in motorsport. It's a challenging place to be. The budgets aren't what they used to be, or at least they're much more focused on the bottom line as they were on just delivery schedule. Yep. But there's aerospace, there's medical, there's kind of those mainstream sort of high-level technology sectors that would associate automotive. But we find clients coming from all over. We get products, artwork. We end up with sort of domestic goods that can do with optimising, looking at manufacturing techniques. Wind energy, so energy is a really exciting sector, but anything with lightweighting, anything where we can save material, change material, recycling. We were even doing some biocomposite work now in point of sale. Wow. So there's legislation changing requirements for end-of-life use and things, which really mean we can find a novel solution to something that perhaps has been made the same way for 30 or 40 years, and suddenly the requirements are changing what the clients are looking for.
And we realise we're not a design consultancy, we are a solution business.
Yep.
Because when we started, it was badged as a design consultancy, but with the experience the team has, consultative, but also creative R&D design, and we're also in quite a unique position against other businesses that we have a holistic view of what's going on across multiple sectors, and therefore we're able to cross-pollinate technologies. So we're working with an aerospace client currently with a technology that they have in the aerospace environment, and we've now secured a research grant to apply that technology into wind energy for leading edge corrosion on wind turbines at sea. So from an existing technology, we've moved it into a completely different sector to create advantage. And again, sometimes supporting our clients in the environments they work. Everybody's busy, especially the SMEs. It's a fast-changing environment. Again, advantage we get is that our clients tend to measure themselves against the competition and the sector in which they operate, and also they're only influenced by the technologies that actually they see and touches them. They don't see what's going on in other environments, and therefore we have the advantage to say, did you know? And I suppose that's the education point. Are you aware of a particular technology that's coming along? And sometimes companies realise that they can be coming to a technological cliff for their business if they don't react. The famous Kodak moment. Digital cameras will never work.
Yeah, exactly.
Will never take off.
Yeah. And I suppose that's the debate where we have currently about education and trying to people to understand what 4.0 means to them as individuals and as businesses.
Yeah, you mentioned additive manufacturing, and that the point you mentioned, which was the pitfall often is just 3D printing the existing part that you already make, if that makes sense. So just producing it in a different way. How do you help organisations think differently, and actually fundamentally redesign the products that, or the components that they are looking to produce?
I mean, that point is the same with composites, same with additive. Traditionally you see these parts that someone's struck up, making composite, or making steel, putting composite, or injection mould. Now it says 3D print. And really, I mean, it's helping our clients understand the technology, the capabilities of technology, the kind of design for manufacture information, how you address the challenges. So, all of these technologies have advantages, but also have some challenges linked with them. So it's working our way around, how you integrate parts together. 3D printing, brilliant. We now can print things inside things that we couldn't do before, but is that a benefit? So for us, that is for us to have to understand the technology and its limitations, but also how to take the best out of it, and then two, to kind of steer our clients, at least in their thinking to start with, and that's at a much higher level. So you get the client that says, well, I want to 3D print everything, and you're like, how many of them do you make a year? Well, I make 100,000 a year. Like, well, here's some quick numbers. You need 20,000
Are you
machines.
sure?
So I mean, a little bit wide, but that kind of, there's a step back from getting into the detail straight away from a design point of view, but actually looking at the commercials and the logistics of it, saying, actually, that isn't quite ready for it yet. However, maybe there's an interim step. So it really is, as Mike mentioned, we really want to collaborate with our clients and challenge them respectfully, but also add that value by not just going, we'll do that, when that might not be what's best. And then really, if you want to really get them on board, it's looking at a program to engage them into that technology in a low risk, low cost way. If they need some hand holding, they need some kind of gentle leading into that, and supporting that in a way that's, not sort of, come in, we don't know everything, but we might know a little bit more than you, and that might be enough to help you get where you want to go.
And what about materials? Everyone's comfortable with sort of rapid prototyping and making your first off design verifications, for want of a better word, but particularly for automotive and aerospace. Are there really materials that are type approved for those applications?
Yeah, they are close. On the metal side, I know there's some metal parts that have flown. There are definitely some polymer parts that have flown. There are some aerospace approved 3D print polymers. The metal side of things taken a little bit longer. I think just to characterise the properties you get from an additive component, certainly from a motorsport, automotive, and obviously flight is one issue of concern, just because of the risk of parts not working. But in other industries which can be perhaps a little bit bolder in getting technologies into it, the customisation of cars, we look at special vehicle type of applications where you're customising your interior and things, 3D printing bits of dashboard, bits of grills and things, it works. You can metal coat them. We make test components for a client which will ultimately be injection moulded, but those test components we take over the road and we stick 4.5 tons of static load on them. This is an automotive project. We've run tests on them. We've broken world records with 3D printed parts in this particular run flat sector. So they can be functional. I think there's a consistency that's becoming known and understood, and it's only ever confidence in the user. It's only all the stuff that we do now in casting and machining, it's been learned over decades, and we're learning it in additive at a much faster rate, but we still have to get the confidence that print will be the same every time. And that's the bit that's...
It's a repeatability factor currently,
But I mean, I don't think that's far away. In the metal side of things, the aerospace companies, they're the grail is to print blades, turbine blades. I don't suspect they're too far away from that. Maybe they're even testing them. But I think there's that. They might have the technology there already, but the qualification is the bit that's the delay. So whether other industries can add to that confidence, whether the testing and the understanding is sufficient enough to speed it up. But certainly, I would say now we don't see it as a prototype technology. It's a manufacturing technology that we may use for prototype, but we may also use it for production if applicable.
And thinking about the environment, the business environment, is there anything that government could do, or organisations like EEF, to help accelerate the adoption of some of those technologies?
I think it's just the education and creating awareness. So the issue with 4.0. There's a lot of businesses that really don't understand, and again, they're just day to day trying to survive, and it's still trying to get organisations into that R&D culture. And in simple terms, from a business point of view, we'll look at where their particular product is on the life cycle, And if it's coming to the top of the life cycle, you're high volume, low margins, there's a point where you need to change and invest to allow your business to move forward. So, helping them with strategy, business strategy, R&D investment, and then the introduction of automation or cobotics and materials. It's right across the board. And I think the assumption is that it's just too expensive, isn't it? We just can't afford it. But
I think if you can, getting it out there, case studies, so people can see where it's been used, but probably where it's been used in a more mainstream application, if possible, might give people more confidence. And I think that assumption, we all know what they say about assumption, and for us as a design business, it's a double-edged sword. We never assume if we can avoid it. We always have data, but if we have to make assumptions, because sometimes the briefs that we get from our clients are pretty loose, and so we make assumptions that we feed back to them and we agree on how to take a design project forward. But actually, that assuming that the technology is not ready or the material properties aren't there or the cost is too much, I think that's probably half the problem, maybe even more than half the problem, because people just dismiss it. And that what could have been when we should really explore this is just moved away, and more traditional methods maybe are considered or taken, and they might not be the best approach at that time. So anything to raise awareness. The UK has a massive challenge with its perception of engineering. Fundamentally, what the UK public think engineers do. And I think 3D printing's really captured the imagination. And anything linked to that and technology, composites in road cars, probably similar, but maybe not to the same scale due to accessibility, but anything to get the British public thinking of engineering as a professional career, job with high technology and
So do you think the digital revolution, going back to the fourth industrial revolution, the fact that we are going to be merging technologies, so yes, you need to understand how to make products, you need to understand how to design products, but overlaying with that some of these digital requirements, in my mind, that opens careers up to young people that historically would have thought, I don't want to go anywhere near engineering or manufacturing. But suddenly with driving apps and interfacing with a lot of these systems and these designs.
And that's right. You look at what percentage of advanced engineering is digital. It could be anything 75-80% of advanced manufacturing. You're looking at 4.0. And then the jobs that are being created through that, people haven't realised it. And it brings back to the skills factor. I know, because there's going to be a shortage of skills, and we're not going to be able to fill that gap. So therefore, productivity, automation, the digital revolution people are going to be forced down that route whether they like it or not, so they really need to pick it up and educate themselves. Large organisations are in a unique position because they can afford to create R&D cells within their business and look at new operations to survive. But even look at collaboration. The larger organisations are now working together collaboratively to try and create solutions for the future. And again, SMEs in the right space are being supported because the OEMs are becoming more collaborative with the SMEs because they're more dynamic, they're fast moving, and can move at pace. But there are some businesses that are being left behind, and I think the skills shortage is going to bring it to the fore.